Hello and welcome to the final section, Recent Models and Developments. In this section, we will cover two upcoming techniques that have engaged huge interest in the field, generative adversarial networks and the whole reinforcement learning field. Now we move on to the first video of this section, GANs. In this video, we are going to learn about generative adversarial networks. GAN stands for Generative Adversarial Networks. They are a new kind of unsupervised learning model, one of the very few disrupting models of the last decade. They have two models competing with and improving each other throughout the iterations. The architecture was originally based on supervised learning and game theory, and its main objective is to basically learn to generate realistic samples from an original dataset of elements of the same class. GANs allow new applications to produce new samples from a previous set of samples, including completing missing information. It's worth noting that the amount of research on GANs is increasing at an almost exponential rate, as depicted in the graph. To understand the concept of adversarial networks, we will first define the two models that interact in a typical GAN setup. The first model that we define is generator model. The generator is tasked with taking in a sample from a standard random distribution and producing a point that looks sort of like it could come from the same distribution as XX. The next model that we define is discriminator. Discriminator is tasked with discriminating between samples from the true data and the artificial data generated by the generator. In the general case, both the generator and the discriminator are neural networks, and they are trained in an alternating manner. Each of their objectives can be expressed as a loss function that we can optimize via gradient descent. The final result is that both models improve themselves in tandem. The generator produces better images, and the discriminator gets better at determining whether the generated sample is fake. In practice, the final result is a model that produces really good and realistic new samples. That's all about GANs.